The strategy pattern is used to pass different algorithms or behaviors to an object. So first, let's consider an application that stores videos. Before storing a video, the video needs to be compressed using a specific compression algorithm, such as MOV or MP4. Then, if necessary, apply an overlay to the video, such as black and white or blur. So let's create a video storage class to handle this situation. So first of all, what we want to do is create some enums for the compressor types that we have, and also for the overlays. So first of all, let's create the compressors, and this is going to be an enum, and we have MOV, MP4, WebM, and then let's create the overlays. So we're going to have another enum for overlays, and we're going to have no overlay. We're going to have black and white, and we're also going to have a blur overlay. Okay, and the reason we create these enums is because it's better practice than using hard-coded values. For example, if overlay is equal to, this should be just overlay, by the way. See, will it let me? If overlay is equal to MOV. So this is bad practice because we're hard coding a literal string value into the conditional. And one of the reasons why this is a bad practice is because, let's say we want to change the name of this extension, we would then have to search through all of the code and change the values one by one. Whereas if we have an enum and we want to change, the name of the MOV extension to MOVV, for example, then we can just use our VS Code or our text editor, and we can, on Mac, I can press function F2 and I can rename to MOVV, for example, and that will change all through the program. Okay, so that's why, one of the good reasons why using an enum is good practice. Okay, so now let's create our video storage class. So let's create a new class called video storage. And our video storage class is going to have two fields. It's going to have a compressor field, and I'm just going to give this an underscore because it's a sort of convention in C#. And we're going to have an overlay. Okay, and now we need to create a constructor where we pass the compressor that we want to use, and we also pass the overlay that we want to use. But if the user doesn't want to use any overlay, what we can do is by default provide a default overlay of none. Okay, so if the user doesn't supply an overlay when they create the video storage object, then we're just going to apply no overlay. Then in here, we can just say compressor equals compressor, overlay equals overlay, so set the values of the fields. And then I'm just going to create a couple of setter methods here, so that once the video storage object is created, we can change the compression algorithm or the overlay that is used in the video storage object to store videos. So let's create a getter called setCompressor, and this is going to take a compressor, and we can just set the compressor. And we'll also do the same for overlay, so that the overlay can be updated, so that we can use the same video storage object with different overlays and compressors. Okay, and then we're going to create our store method, which will contain the logic for storing a video. Okay, so this is going to take a file name, and we're going to perform a check where we check if the compressor is equal to compressors.move, MOV. Then we will have some logic for compressing a video using MOV. But of course, that's beyond the scope of this course, so we're just going to log compressing using MOV. Okay, and then we're going to have another conditional if it's an MP4, and then we can just copy this down and say compressing using MP4, and then we're going to have the same kind of thing for if the video is a WebM. If the compression algorithm is WebM. So this is all of our logic related to compressing the video. And then we also need some logic for applying an overlay to a video. So I'm just going to write overlay logic here. And then I'm just going to copy in this overlay logic to save some time. So let's copy that in. And I just need to change this to not all capitals. Okay, and then at the end we can simply store the video to the file location. So we will say storing video to file name, and this should be here. Okay, and then we can also concatenate on the extension as well. So compressors, actually compressor dot, yeah, it's just the compressor, isn't it? Okay, so that will give us the file extension. Okay, so that is our video storage class. So let's now discuss some of the problems with this solution. So first of all, it violates the open-closed principle, because adding new compression algorithms or new overlays means that we have to modify the existing video storage class. So this working and tested code has to be modified, which risks introducing bugs to previously working code. And also developers could get lots of merge conflicts in Git, as multiple developers may have to edit one big class. For example, if one developer is working on compression algorithms and another developer is working on overlays, then both developers will be editing this video storage class, which means that developers can sort of step on each other's toes and things can get kind of difficult to work with and messy. Okay, so you can also see that this is a very bloated video storage class. This method is difficult to follow, even with just 3 overlays and 3 compressors. So you can imagine the more compressors and overlays we add, the more bloated and difficult to read this is going to be. So let's now try to solve this problem using the strategy pattern. So the UML below shows that when we create a video storage object, we pass it to the concrete compressor and overlay objects that we want to use. And this is polymorphism, so video storage can accept many different forms of compressor and overlay objects. Video storage is composed of compressor and overlay objects, as represented by the arrow with a diamond. And there are multiple concrete compressor and overlay implementations that extend the compressor and filter interfaces respectively. So you can see here we have our video storage class, which is composed of a compressor and an overlay. And our video storage class is talking to or coded to an interface, not a concrete implementation of a compressor or overlay. And this provides us with a lot of flexibility, because we can very easily swap out the compressor that the video storage is using or the overlay, as long as they implement the compressor or overlay interfaces. Okay, so this is the strategy pattern, and now I'm going to show you how it looks with the abstract class names from the Gang of 4 book. So you can see that our video storage class is known as the context, and the context is composed of or stores a reference to a strategy. Okay, and the strategy is represented by an interface, and then we have concrete strategies each with some sort of method. Okay, so if we have a look at our solution, our video storage is the context, which has a reference to a strategy, and currently we have two different types of strategy in our video storage class. We have compressor and overlay strategies, or algorithms I guess you could call them. And then we have our concrete strategies, which implement these interfaces. Okay, and you can see here in the context, or in the video storage class, when we call one of the methods, we are now delegating work to a concrete strategy, okay, rather than actually doing the logic within the context object itself with all the if, else conditional statements. We can just simply delegate the work to the concrete strategy object. So let's now implement this in code. So first of all, let's create the interfaces for our two strategies. Our two strategies being the compressor and the overlay. So I'm just going to create a new folder here called Good Example, using the strategy design pattern. And in here, what I'm going to do is I'm going to create a compressor interface called iCompressor. And in C#, it's generally considered good practice to start interfaces with the letter I, so prefix with the letter I, so that it's clear that it's an interface and not just a class. And in here, we're going to have a single method called compress, which returns void. And then we're going to create another interface called iOverlay. And this is going to have a single method called apply. Okay, so now we have our interfaces, or our strategy interfaces. We can create the concrete, our concrete strategy object classes, and we have two strategies. So we're going to need two sets of concrete strategy objects or classes. First of all, let's start with the compressors. So I'm going to create a new C# class called compressor MOV, and this needs to implement the iCompressor interface, and then we can implement this interface. And what we're going to do is we're just going to log compressing video using MOV. Okay, and then we're going to do the same for MP4 and WebM. So let's quickly do that. So we can say compressor MP4, and I'm just going to copy this in to save some time. So it needs to implement the iCompressor interface, and then we can have our compress function method, and then we're going to do the same for compressor WebM. Okay, so those are our concrete compressors. We can now create our concrete overlay strategies. So first of all, let's create the black and white. And this needs to implement the iOverlay interface. And we can implement that. And here we can just put applying black and white overlay. Okay, and then we also need a overlay for the blur strategy. And then we need a And then let's actually call this, make sure that we prefix with compressor. And the reason I like to do this is because then they all kind of stay together in VS Code. So let's just change the name of this. And we just need our compressor for, our overlay for none. Actually, this should be overlay, sorry, apologies. And let's make sure this is correct. Okay, and yeah, what are we doing here? So this should be I overlay. Okay, so let's change this to apply, get rid of this. Okay, so that is correct. And now we need our no overlay class. So overlay none. And this should be I overlay. Implement and not applying overlay. Okay, so now we need to create our video storage class. So what I'm going to do is I'm going to copy and paste the class from here, and then we're going to refactor this class to make it sort of satisfy the strategy pattern. So let's create a new class called video storage. I'm just going to paste in what we had before. Okay. So how do we refactor this to satisfy our strategy pattern? Well, first of all, we need, rather than coding to these enums, we're going to change this so that the compressor is coded to the compressor interface. And we're going to do the same for overlay. And we also need to update this to iCompressor. And this needs to be updated to iOverlay. Okay. And we also need to change this to iCompressor. This should be iOverlay. And now the biggest changes are going to be in our store method. So currently all of the logic for compressing a video is stored in this store method, and also all of the logic for applying an overlay is in here. So what we can now do is we can get rid of all of this, and we can delegate this work to the concrete compressor and overlay objects. So video storage will have no knowledge of the implementation details of each compression and overlay algorithm. So we can say compressor.compress, and we can say overlay.apply. Okay, and in a real application, we probably need to pass the file name to this compress method and also the apply method, so it can get, or maybe pass a video object, something like that. But for now, we're just going to keep things simple, and we're just going to call the compress and apply methods. But as you can see, we no longer need to check what the compression algorithm should be. We also don't need to check what the overlay is that we are applying. We just simply call the compress and then compress method, and then we apply the overlay. So this is way more simple than we had before. So let's actually now have a look at how a client would use this solution. So we can create a video storage object. And it should be this one, and then we can pass in a compressor. So let's just pass in a MOV compressor. So we want to compress to MOV. And for the overlay, let's do black and white. Okay, so let's actually call the store method. And let's pass the file name. So let's just say the file location is videos / some movie. Okay, and then let's see what happens here. Okay, so we've compressed the video using MOV, applied black and white overlay, and then the video has been stored. Okay, so that's good. And because we added setter methods onto the video storage class, so if I just go back into here, we can see we added set compressor and set overlay methods. So that allows us to change the compressor or the overlay that we use within the video storage class. We don't have to create a new video storage object just to use a different compressor, for example. So say we wanted to use a MP4 this time, and the overlay, we wanted no overlay. So if we just said overlay none, oops, sorry, this should be just the compressor, and then we can call video storage.set overlay and pass overlay none, and then we call video storage dot store, and then we pass some location, videos / some movie. We can actually compress and set an overlay for the same video, but we can use a different compression algorithm and a different overlay just by calling these set methods. Okay, so these setter methods give us a little bit more sort of flexibility with the way that we use the video storage object. Okay. So this is great. So this solution follows the open-closed principle. For example, to create a new compressor, so a new concrete compressor, we simply create a new class that extends the iCompressor interface, which is this, and our code is extended. So our code base is extended, meaning that we've just added a new class, and not modified, meaning that we don't have to modify any existing classes to add a compressor. And same for overlay. So now we can just extend our code base, so we can add a new overlay or add a new compressor, and we don't have to modify any existing code to do that. So you may be wondering, what is the difference between the strategy and state pattern? Because the two patterns probably seem quite similar to you. And the truth is, the two patterns are actually similar, and the difference between them varies depending on who you ask. And some popular answers to this question are that states store a reference to the context object that contains them, whereas strategies do not. States are allowed to replace themselves, in other words, to change the state of the context object to something else, while strategies are not. And strategies only handle a single specific task, while states provide the underlying implementation for everything or almost everything that the context object does. So when should you use the strategy pattern? A good rule of thumb for when it might be a good time to reach for the strategy pattern is when you have a class with a large number of conditional statements that switch between variants of the same algorithm. So in our video storage class, we saw that there were a large number of conditional statements that switch between variants of the same algorithm. So the algorithm being a compression algorithm, and the variants being .mov or MP4. And we could see that by switching to the strategy pattern, we got rid of all of those kind of bloated, messy conditional statements. And the algorithm logic can be extracted into separate classes that implement the same interface. And that is what we did with our solution. We extracted the compression logic as well as the overlay logic into separate classes that implemented either a compressor or overlay interface. And the context object, in our case the video storage class, then delegates the work to these classes instead of implementing all of the algorithms itself. So the pros and cons of the strategy pattern. So the pros, it satisfies the open-close principle because we can add new strategies without modifying the context or class. And we can swap algorithms used inside an object at runtime, so it provides lots of flexibility. And some of the cons of the strategy pattern are that clients have to be aware of the different algorithms and select the appropriate one. So in our program.cs file, we had to pass the we had to pass the strategy, the compression algorithm or the overlay object that we wanted to use. And if you only have a few algorithms that rarely change, then using the strategy pattern may be over-engineering because we're creating potentially lots of new classes, and it's not really necessary if there are only a few algorithms that aren't going to be changing often.